it's shockingly easy for attackers to disable Windows Defender, with a big asterisk. The method that I'm going to talk about in this video requires physical access to the device, which I have to this device here, and I will demonstrate how it works in a bit. The interesting part is that this method even works if the hard drive is encrypted with BitLocker. I believe that this attack vector is less of a threat to normal end users, but more to organizations. And don't get me wrong, I think that Windows Defender is actually quite good, especially for something that is free. Way better than some of the other freemium crapware that constantly nags and tries to upsell you to buy a better package. And with the Microsoft Defender for Endpoint subscription, it gets enterprise ready with management and reporting functionality. Anyway, the underlying problem applies to all other antivirus/endpoint protection products too, as far as I understand. So let's imagine this. I take the role of an attacker who wants to execute some malicious code on a victim's computer. Maybe I just snuck into the company's office and the computer was not locked, or maybe I even found out the user's password because it was on a post-it note at the screen. And you might think that this could already be enough for some attackers. They already got the password, they can access the user's data, but really, it depends on what the attacker is after. Nowadays, in a lot of cases, attackers want to retrieve more data than one particular user has access to, maybe even to all systems of a company. And if they can install malware on one system, that's a first foot in the door. But in this case, the company's IT department did at least some of their homework. The normal end user has no administrative rights, and the hard drive, or rather SSD in this case, is encrypted with BitLocker. So I can't just go and disable Defender using the normal way. Attention! The following demonstration serves only learning purposes. We need to understand how attackers act or could act to protect ourselves and our computers. We can only plan our protective measures if we know what to protect against. And it's probably illegal in your jurisdiction to do the following things on a computer that is not yours, or if you don't have explicit approval to do so. So don't do it. Here comes Nuke from Orbit, or short NIFO, made by Lars Karlslund into play. It requires no administrative rights to execute. I already have it on a USB drive here. I'll quickly open a terminal, use CD to change directory to the USB drive, and execute nifo-x64.exe generate --mode bash. That command uses the Windows defragmentation API to locate the exact sectors on the disk where all the important executables for Windows Defender reside. And it outputs a bash script, which we will use in a sec. To actually save this script, I'll redirect the output to a new file named nifo.sh. That's all the preparation needed, so it really only needs a few seconds of unattended access to an unlocked device. Next step is to reboot the computer into another operating system. In this case, there's nothing preventing me from doing so. The system even has Secure Boot enabled, but the Linux bootloader is signed, so Secure Boot doesn't matter. I already prepared a second USB drive with Linux Mint on it. Since this is a completely separate operating system, it is not bound by the configured permissions in Windows. And if the hard drive was not encrypted, it would be really easy to remove or manipulate the files needed for Windows Defender, just like that. But since the drive is encrypted on this computer, we can't just go there using normal procedures and do something with the files. Anyway, thanks to NIFO, we know exactly where all the important Defender files are located on the hard drive. It doesn't matter that we can't write any meaningful data to the drive, meaningful as in that data would work in Windows. Instead, the generated NIFO script writes 64 bytes of zeros at the beginning of each Defender file using the dd utility, which will prevent the executables from running at all. The rest of the system will be untouched and will still continue to work. So let's do it. I'll launch a terminal in Linux, use cd to change to my USB drive, use chmod +x to make the NIFO script executable, and then one more step. I run lsblk to check my devices, or rather my block devices, my storage devices. And I see that my SSD is called SDA, and the biggest partition is SDA4. So that's the one with 78 point something gigabytes. With that info in mind, I can run NIFO, but I need administrative root rights, so I'll use the sudo command, then ./nifo.sh, nuke is the parameter to nuke the drive or nuke defender, and then /dev/sda4. That ran really fast, and yeah, it's already done. Let's reboot back into Windows. Since I know the password of the user, I can log in as them now. In a scenario where an attacker doesn't have the password, Defender would be at least disabled now, even though they don't have a way to confirm that and make use of it immediately. But they could still try to manipulate the user into executing something malicious later on. Okay, first thing here, back into Windows. We note that Windows Defender is still green in the tray, so it's not even aware yet that Defender is defunct now. If we double click that and look into the Windows Security Center, we see that it's somehow loading here. It's not sure yet what's happening. After a minute or two, it will realize that something is wrong, but it will not fix the issue automatically. So as an attacker, I could run some malware now, which normally should get detected by Defender. I got some stuff here on my USB drive to demonstrate that. For example, I can run WinPeace-ng now, which is a tool that tries to find common misconfigurations and security vulnerabilities that an attacker could use to gain admin rights on a system. In the meantime, the system has realized that it's not protected anymore. Or I can run the infamous Mimicuts, which would theoretically allow me to dump credentials, but I still don't have admin rights, so I can't fully utilize it. That's all that I wanted to show in the demo. So let's review what happened here. How does it work? Microsoft Defender or any other endpoint protection software needs to have its executable program files somewhere on the system. How else could it run? And a normal end user is not allowed to mess with these files. Not even admin users are allowed to do that. But the files reside on the hard drive, only protected by their NTFS permissions. NTFS is the standard file system in Windows. The problem is, these NTFS permissions are only enforced by Windows, taking the logged in user into account. So if I boot up a Linux live system, or even plug the hard drive into another Windows system, it would not be bound by the accounts of this one Windows instance. So I can just do whatever I want with the files on the system, for example, removing all important files for MS Defender. And the integration of Defender into the rest of the operating system is not enforced. The system will still boot up and work in a normal way, even if Defender can't start. But again, in this scenario, the hard drive, or rather the operating system partition of the drive, was encrypted with BitLocker. So that is something that other operating systems can't just ignore, because the data on the drive is not readable in plain text, just gibberish without the key to unlock. Anyway, BitLocker only prevents unauthorized people to read the actual data on the drive in their decrypted form. It's not preventing someone to write to the encrypted partition, but without the correct key, the data that we write makes no real sense. That means we can't manipulate data to be something else that makes sense there. So we can't replace any program with a piece of malware or change infos in a document on the drive. We can, however, destroy data by overwriting it. And even partly overwriting the beginning of a program prevents it from running at all. Normally, with an encrypted hard drive partition, we can't know where exactly a specific file is located from the outside. Time for a little inside job. Even a normal user can get these infos using a specific Windows API or syscall. I'm not 100% sure about why, but it's possible to retrieve the relative offset where a file is located on the partition. Might have to do something with the defragmentation API. Let's add all of this together. We retrieve where exactly our endpoint protection software is located on the drive. We use a Linux Live system to write some meaningless data to these locations on the drive. We boot back into Windows, which still works, because there are no checks in place which would only allow the system to work with a running endpoint protection software. How can we protect ourselves now against an attack like that? We need layered defense. So we need to have all of the following. The BIOS or UEFI settings need to be password protected. The boot order should be locked down so that it's not possible to boot from USB drives, DVDs or PXE boot via network. It should only be allowed to boot from the correct hard disk. The hard drive should be encrypted, for example with BitLocker, but the hard drive should also be locked with a hard disk password. For example, on my HP laptop, the option is called Drive Lock. Once it's enabled, it's not possible to mount the disk on another computer at all. If any of these measures are not implemented, then the system is vulnerable to the NIFO attack. Now, you just need to ask yourself if that is something that you need or want to protect against. Physical access, I know, that's a completely different level. For the average home user, I think the risk is pretty low. As an organization, on the other hand, I think there's more potential risk. If you have to worry about really dedicated and persistent attacker groups, NIFO could be an issue and you should prepare. Finally, a big shout out to Lars Karlslund, the creator of NIFO. Really cool stuff, great work, thank you. And I hope you found this interesting or useful. If you would like to help me out a bit, please like this video, write a nice comment and subscribe to the channel to boost this video. Thanks for watching, bye.